This is your second lesson on the Pythagorean theorem, and since we're using the Pythagorean theorem, we really should be able to prove the Pythagorean theorem because we're using something very important. We should know why it works. So there's several different proofs, and this proof is going to start off with the fact that we have a right triangle, and we're going to label the sides of that right triangle A, B, and C, C being the longest side. And we know that the area of a triangle is 1/2 base times height, and so in this case that's the B and the A, so the area of that one triangle is 1/2 BA. Now we're going to duplicate this exact same triangle and then just turn it on its side and place it right next to it so that this one side is collinear, so I have the one side that's B and an A there. And that triangle also has the area of 1/2 B times A. We're going to copy that triangle yet again and turn it and place it up on top here. And once again, that triangle has the area of 1/2 base times height, or 1/2 BA, and a fourth copy of that triangle. And again, the area is 1/2 base times height, or BA. So I've got 4 triangles, all with the same area, 1/2 BA. So the area of all 4 of those triangles is going to be 2AB. But I also created this inner square that has dimensions of C by C. All the sides of that square, I'm going to highlight it in red now, is C. So since all the dimensions are C, the area of that square is C squared. So I know that the area of this figure that I just created, this big outside square, is these two things added together, 2AB plus C squared equals the area of all of that. But I also noticed that the length of any one of the sides of the great big square is A plus B. So if I square each side, I'm going to get the area of the big outer square. So the area of the big outer square is A plus B quantity squared. To actually square that, that's a binomial squared, A plus B, the two terms being squared. I know that I can break that up and I can distribute, or that foiling, distribute those, and I end up getting A squared plus 2AB plus B squared equals the area of that great big outer square. But remember what I said earlier, that over here on the left, that also was the area of the square. So what I have is the big square has area of A squared plus 2AB plus B squared, and that's going to equal the 4 triangles, 2AB, plus the inner square C squared. Now notice on the left side and the right side of the equation I have a 2AB. So I'm going to get rid of that since it's on both sides, and that's going to go away. And then bringing it down, I see what I'm left with is A squared plus B squared, which equals C squared. And that's the Pythagorean theorem. So this is one proof of the Pythagorean theorem.